Today's topic is matrix. Now, what is a matrix? Matrix is a set of numbers arranged in rows and columns so as to form a rectangular or square array, just like this. And it is given in third bracket, within third brackets or first bracket, and the entries in this are known as elements of the matrix. Previously, the matrix was used to solve linear equations. Here, the horizontal portions are known as row and vertical lines are known as column. Suppose we have an example 1, 2, 3, 4, 5, 6. Here in first row 1, in row 1 the elements are 1, 2, 3. In row 2 the elements are 4, 5, 6. If you see from column, in column 1 the elements are 1, 4, and in column 2 the elements are 2, 5, and in column 3 the elements are 3 and 6. Okay, now we are going for order of a matrix. Order of a matrix is the number of rows and number of columns with which it made. Now in the previous one, number of rows are 2 and number of columns are 3. So just like a rectangle, we can say that its order is 2 by 3. Its order is 2 by 3. Now it may be. Now the next one is what kind of matrices are there. Number 1, rectangular. Rectangular matrix means where number of rows is not equals to number of columns. Next, number 2, square matrix. Where number of rows and number of columns are same, like 1, 2, 3, 4, where it is 2 by 2. Okay, next one, number 3, row matrix. Row matrix is a matrix which consists only a single row. There are number of columns, but the number of row is 1. That means just like 1, 2, 3. Okay, in the same way, column matrix. Column matrix. In column matrix, a matrix that contains a single column. Number of rows varies, but contains only a single column, like this 1, 2, 3. This is a column matrix. Now the next one is null matrix. Null matrix means it may have any number of columns or any number of rows, but every element or every entries of that matrix should be 0. If all the elements are 0, then it is a null matrix and it is denoted by capital O, and all the matrices are denoted by capital letters. Next one, equality of two matrices. Equality of two matrices means, suppose we have a matrix Aij which is order m by n. That means it is a short form of a matrix. It will be denoted by A11, A12, A13 and so on, A1n, A21, A22, A23 and so on, A2n, and continues like that. Last one is M1, M2, M3 Mn. It's a general form of a matrix. Okay, so for equality of matrix, suppose we have two matrices. One is Aij, its order is m by n, and another one is Bij, whose order also p by q. Now first thing, the order should be same. That means both of the matrices should have same order. That means m equals to p and n equals to q. And next one is the corresponding element should be same. Just like suppose we have here a1, a2, b1, b2 in A, and in B suppose it is a1, a2, a3, a4, and in B it is b1, b2, b3, b4. Look, the order are same. Now again, the corresponding element means the position here, this should be same, this should be same, like this. That means a1 equals to b1, a2 equals to b2, a3 equals to b3, as well as a4 equals to b4. If all the corresponding elements are same, then we can say that the two matrices are equal. Now the next one is diagonal matrix. Diagonal matrix, when we are going to learn about diagonal matrix, a diagonal matrix should be a square matrix. In any rectangular matrix, it never forms a diagonal matrix. Okay, so what is a diagonal matrix? Diagonal matrix is a matrix where all the elements, suppose I am taking 3 by 3, then all the elements A 0 0 0, B 0 0 0 0, look at the diagonal, it forms a diagonal. In rectangular it never forms a diagonal from first to the last, following every row or every column. Okay, now if the diagonals, the elements of the diagonals are non-zero and others are 0, that means at least one of the elements should be non-zero. Or suppose that means the diagonal elements are non-zero and others are 0, then it is a diagonal matrix. Clear? Now next one is scalar matrix. In scalar matrix, just like a diagonal matrix, if all the elements of the diagonal are same, then it is a scalar matrix. And next one is identity matrix. In an identity matrix, if the diagonal elements are 1, that means 1 0 0 0 1 0 0 0 1, then it is an identity matrix. An identity matrix usually denoted by I or by its order, that means I3, as it is a 3 by 3 matrix, so it is given as I3. So I2 will be a 2 by 2, so 1 0 0 1. Okay, so this is identity matrix. Now we are going to the operation of matrices. Operation on matrices. So the first operation is addition. Addition of two or more matrices. Look, addition and subtraction are same. Addition or subtraction. Addition and subtraction are same. Only to remember one thing, that in addition or subtraction, the matrices should have same order. Don't have to be the same element, but the order of the matrix should be same. If the order of the matrices are different, then they can't be added or subtracted. So, and how they add it? Very simple, just add or subtract the corresponding elements. That means suppose we have a1, b1, or a1, a2, a3, a4, and we are adding it with b1, b2, b3, b4. I have taken square matrices. It may be rectangular. Just remember the order should be same. So it will become, just add the corresponding a1 with b1, a3 with b3, a2 with b2, and a4 with b4. So it become a1 plus b1, a3 plus b3, a2 plus b2, and a4 plus b4. If you subtract them, just same thing, they just subtracted. Okay, next one is scalar multiplication of matrix. Scalar multiplication means, suppose A is given a1, a2, a3, b1, b2, b3. Now we are going to multiply a constant, suppose 5 with A. That means 5 is multiplied with this matrix. It means it will be multiplied with each of the elements inside the matrix. That means it will become 5a1, 5a2, 5a3, 5b1, 5b2, 5b3. So when you multiply a constant with a matrix, it will be multiplied with each element. And reversely or conversely also, if some elements, same elements are multiplied with every element of a matrix, you can take common, just one scalar will come, okay, from every element. If every element is not a multiplier of that number, then you can't take common. So okay, next one is transpose of a matrix. Now what is transpose of a matrix? Suppose we have A is equals to a1, a2, a3, b1, b2, b3. Transpose means just take the row and convert into a column. Like this is a row, but in transpose it will be a column. That means a1, a2, a3, and b1, b2, b3, and it is denoted by a to the power small t or a to the power capital T, or simply by a dashed. This is transpose of a matrix. Okay, the next one is symmetric matrix. If we have a matrix and if we take its transpose, if it remains the same, then it is a symmetric matrix. Suppose we have an example of A, B, C, so we have a 3 by 3 matrix. Now we are going to take its transpose. So now this row becomes the first column, this row becomes the second column, and this row becomes the third column here. Now look, it remains same. That means it will be A. So here A is a symmetric matrix. Next one is skew symmetric matrix. Skew symmetric matrix, same. Suppose we have a matrix A and we are taking its transpose, it will become the same but with opposite sign. Then it is a skew symmetric matrix. Suppose we have an example. Suppose we have 0, A, B, minus A 0 C minus B minus C 0. Now you are going to take its transpose. So here this row becomes the first column, this row becomes the second column, and this row becomes the third column. Now if we take minus common, we have to take minus common from each of the elements. So whoever having minus, it will become plus, and whoever having plus sign, they become minus. So if we take minus from here, what it become? 0 minus A minus B, A 0 minus C, B C 0. Now just look at the sum, look at the matrix. It will become the same as the previous one. So here as A transpose becomes minus A, so here it is a skew symmetric matrix. Okay, and the last one is any matrix can be expressed as a sum of two symmetric and skew symmetric matrix. Okay, look, we can write A as half of A plus A transpose plus half of A minus A transpose. Now look here, if you split the bracket, A transpose portion will be cancelled and half a become A. So A can be expressed as A plus A transpose and A minus A transpose. Now we are going to prove the first portion will be a symmetric one and the second portion will be a skew symmetric one. So to prove it is a symmetric one, we have to do its transpose. Okay, so it will be A transpose plus A transpose is transpose. Now there are some properties of transpose. Look here, there are some properties of transpose. In which the number one is, if we are taking addition then transpose will be distributed for subtraction also. If we take a multiplication then it's transpose, then in transpose it will become B transpose A transpose. And number three, if you take transpose as transpose, then it becomes the same matrix again. And also remember one thing, if A is Aij with order m by n, then A transpose become Aji with order n by n. Remember this thing. Okay, now we are going towards this, so it will become A transpose plus A, that means remains the same, that means half of A plus A transpose is a symmetric matrix. Now for the second one, if we take A transpose, its transpose, the second one, so it will become A transpose minus A transpose is transpose, that means A transpose minus A, that means we have to take common minus, then it will become A minus A transpose. That means here it satisfies the property of skew symmetric matrix. So half of A minus A transpose is a skew symmetric matrix. So our conclusion is any matrix can be expressed as summation of two matrices in which one is symmetric and the another is skew symmetric.